Alright, so today it's day 53. What I did was mostly just I did 2 lead codes, that's it. It took me, quite some time. Maybe I should start seeing the solutions much faster. And what I did was these 2 problems, the 2-sum 2 and the 3-sum. Yeah, for the 2-sum 2, my solution was this one, and it was essentially the same as the one presented in the solutions. My solution, it's you have a list. It's essentially the 2-sum, but they give you an ordered list, but it's the same objective, which is to find like the indices of the numbers that sum to a certain target. And now the intuition, it's like that they give that you have to use pointers, and they give you an ordered list. So given this intuition, you can build like a solution, which essentially is I'm gonna start by initializing a pointer in the extreme left and another one in the extreme right, and then I check like the sum of both, the sum given both of the pointers. If the target is greater than the sum, I move the left pointer because it means that I need to make a sum bigger. If not, I move the right pointer because it means that I need to make the sum smaller. And we can see it here because it's order, and let's sum 2 and 15, which is 17. I want the sum to be smaller, so I move this pointer to the left, and now the sum is 13. I want to make it smaller, so now the sum is 2 plus 7. And the intuition here, like the most important thing is like you will always guarantee to find a solution. And you can think about, if there's a solution, you're gonna find it. And you can think about it as if the problem is symmetric, because you're gonna move one pointer to the left. If you don't find a solution and a solution exists, then by moving the pointer to the right, you're gonna find the solution. Because I don't know, I can give like a concrete example. I don't know, 2, 4, 5, 7, and if you want the sum to be, I don't know, okay, I don't have a specific example right now, but if you do like a couple of iterations, you can see why this is true. Yeah, because the thing is like you make the sum, the current sum, like smaller, but maybe you pass it, like now you make it a bit more bigger, so you move to the left. And now what I was thinking when I implemented the solution is like, but I could do this like always, or probably miss a solution. Why it's not combinatorics? Because I could move one to the left and then one move to the right, and then like miss a solution or something. But no, because the size window is monotonically decreasing, and you're exploring like the possible solutions, and that's it. And for the 3-sum, this one was a bit more complicated. I spent most of the time on it, and essentially the way I solve it, it's I perform like an iteration from k to length nums minus 2. So basically I assign k like as the first element, and I move it all the way almost to the end, and then I perform like 2-sum in the rest of the array, and I basically performing 2-sum at every index in the array, but now the target is 0. That's essentially how you solve it. And the thing is, like, I solve it, I had to sort, and then I also implemented like a dictionary because we don't want like duplicate tuples. So I use the actual solution as a string in the dictionary. But I think probably this is very inefficient. Also, now that I think about it, probably a set, it's even better. I don't know. There are probably much. I haven't checked the solutions, but it didn't even work. It certainly worked, but I had to make some tweaks. For example, I have to change my iteration. I start from k, I should have started from k plus 1. And then what else? This is also important. Once you find the nice triplet, you can directly move the pointers, right? And you, instead of using f, you can use lf, right? To skip, because you are doing this here inside, you can have a condition. Like you can optimize a bit some within the iterations, but I got my solution was really awful, really bad. So I gotta, let's check the solutions actually, because I have no idea. I mean, but I think that the intuition is exactly the same. I think so. You do like one for loop and then you do like a while. Yeah. But it's okay. They use a hash map? Okay, no. They handle the duplicates like directly in the indices. Alright, that's it.